Hi, Assalamualaikum. We are from Group Fanstatics 4, which is Group 18. First, me, Muhammad Khalis Fikri.
Second member, Muhammad Zaim.
And I am Roslyn Tima.
And me, Yohani Kamila.
For introduction, for our project is a convocation management system. This project focus on proposing a database design using an ERD model to manage convocation activities. Convocation involve handling graduate records, invitation, gown and distribution, seating arrangement, and admin tasks. Without a centralized system, manual work can cause repeat data error and slow data access. So this project aim to design an ERD model that centralize the data and improve accuracy and management.
So move to the next part, which is problem statement. There are two main problems we identified. Firstly, the convocation tasks like tracking graduates, invitation, gown distribution, and seating are handled separately. And the second part is the data is not accurate and not consistent, which can cause confusion and incomplete reports. So this makes the convocation preparation process more complicated and less reliable.
So we got two objective for our projects, which is the first one is to design an ERD model that centralizes graduate tracking, invitations, gown distributions, and seating in one database. So the second one is to propose all convocation data is accurate and consistent to avoid confusion and incomplete report.
What we expect from this database design, the expected outcome is a database design using an ERD model for the convocation management system. This design will help improve data accuracy, reduce manual errors, and help admin manage convocation tasks more efficiently. Next part is the project scope. For this part, we divide it into two sections, which is a target user and proposed module. For the target user, there are two types of users in the system. First, the admin. The admin can manage graduate records, seating, invitation, gown distribution, and generate convocation reports. Second, the graduate. The graduate information is stored in the system and can be updated when needed. While for the proposed module, it includes three modules. First, the invitation and reporting module. This module manages invitation, tracks statuses, and generates reports like attendee lists, and seating charts. Second is the gown and seating management module. This module tracks gown collection and assigns seats based on the seating plan. Last but not least is the graduate management module. This module manages graduate records, convocation eligibility, and allows updates.
So the next part is ERD. So in this ERD, we have five main entities, which is graduates, seating, invitation, gown, and admins. For the graduate, we have attributes like graduate ID, full name, IC number, tel number, email, faculty, and program. For the seating, we have seat ID, graduate ID, seat row, seat column, and admin ID. For the invitation, we have invitation ID, graduate ID, status, date set, confirmation, and admin ID. For the gown, we have gown ID, graduate ID, status collection, date collection, status written, date written, and admin ID. For the last entity is admin. We have admin ID, full name, email, and role. For this relationship, each graduate must be assigned to only one seat. Each seat must be assigned to one graduate. Each graduate may or may not receive an invitation. Each graduate will receive an invitation, may confirm, decline, or provide no response. Each graduate may or may not collect gown. Each graduate will collect a gown, must return the gown. Each sitting record must be managed by one admin, and each invitation must be managed by one admin. Each gown collection and return process must be managed by one admin, and one admin can manage multiple graduates for sitting, invitation, and gown processes.
For the next part, for SQL and RA example question. For the first question, display the total number of graduates who have collected their gown grouped by the full name of the admin who manage the gown collection process. In this query, we display the admin name and the total number of gown collected under their management. We use a join to combine the admin and gown table based on the admin ID. We only count the gown where the collection status is collected. Finally, we group the total by admin name. For relational algebra, we use selection, join, and grouping to find the same answer in relation algebra form.
Next for question 2. The question is display the full names who are the only ones from the faculty. For example, faculties that only have one graduate. This query shows the names of graduates who are the only student from the faculty. We use a subquery to find faculties that have only one graduate. Then we filter the graduate list to only show those who belong to that faculty. For the relational algebra, we are using projection, selection, and grouping.
So next, this is our part of data definition language, or DDL in short. We show the table creation for the graduate and admin tables using the create tables command. This is how we structured the database based on our ERT. In this table, we create the graduate entity. Graduate ID is the primary key to uniquely identify each graduate. Field like full names, IC, telephone numbers, and emails are required. IC number must be unique to avoid duplicate students. Faculty and programs details are also included to categories to graduates' academic information. We also create the other tables like admin, seating, gown, and invitations using the same structure, including primary keys and foreign keys to link the table.
For DML, the data manipulation language, we provide insert statement to add data into the admin and graduate table. This show how we can insert and retrieve data using select statement to display the store records. This statement adds a new graduate into the graduate table. We insert the graduate ID, full name, IC number, phone number, email, faculty, and program. The same process is done for other graduates, sitting records, invitation, and gown. That's all for our project presentation. Thank you for your attention.